Hi, we're Team Sales Markdown Predictions. I'm James, this is India, this is Yana, and this is Joe. Our project is about predicting sales and stock management. We hope you enjoy our demo.
Okay, so I will be presenting to you our project called Markdown Predictions. And basically what we're dealing is with end of season markdown within the fashion retail industry. So first of all, our team, which was myself and Joe, who you'll see presenting, and then James and India will join us on stage later. So the problem that we've been dealing with is that we have a very inadequate product stock management because it's very manual when you do it at the end of season in fashion retail. So what is happening with more and more companies is that they go out of business. And if you have been following how the high street has changed with the fashion industries, has changed dramatically. And I'm not saying that all of the companies disappeared because of this problem, but majority of them had. So what happens is that if you have to manually manage how to discount the product at the end of the season, you do it based on not necessarily data, but how it's easier for you to do it from a team perspective. And then the decisions that you are made are not by any means science-driven, and all of the figures that you have available are not used by any means. And also it's normally done in Excel, which is, again, not fit for the task, and it becomes incredibly complicated and manual. So the solution that we have come up with is a simple, user-friendly application that can be used by industry experts or anyone else, really. It has a machine learning algorithm behind it. And within the application, it is able to predict how many sales you are able to achieve within the first 2 weeks of sale at a certain discount. And then you, as a human, make a decision based on your industry knowledge that you are aware of what kind of markdown do you want and what is okay and not okay for your company so that the bottom line is not affected. It's crucial that it is done for the first 2 weeks of sale because you want to capitalize on that time of sale period as much as possible because all of the high street goes on sale at the same time, so you want to monetize on that opportunity and be able to clear that stock as much as possible so that your company doesn't go out of the business because you can't manage your stock. So the data that we used was a real-world data set from the company that I work with, so they've provided us with the data. We had 7 seasons worth of data. There was roughly 2,500 items per data set with around 45 features. Because it was a real-world data set, we spent most of our time cleaning it because, as you can see, we have a lot of dashes there and signs and things that you don't really want to have in your data set. So it wasn't a great time, but we got through it. And so one thing that you need to know about our data set is that we had half of it was numerical and half of it was categorical. And so once we've cleaned it, we probably lost half of that data, which was still okay. We were prepared for it. So the model that we ended up going with was a histogram-based gradient boosting regression tree, and the scoring metric that we used was a root mean square error. And once we've done that, our baseline score was 310. Once we obviously fine-tuned our model, based on our data set, we were able to improve that baseline by 60%. So, as I say, because we had categorical and numerical features, we realized that the most important features were the previous week's sales and how many stores had the stock available and how much stock there is. Now, someone who works in the industry, those are not the features that we take into account when we make this decision manually. So that was a big learning experience. And within that, we used correspondence analysis, and we basically reduced the dimensionality of our categorical features. And so now, Joe's gonna demonstrate to you the tool.
Thank you, Yana. So yeah, this is the tool. Just to kind of set the scene a bit, I would be using this if I was, a merchandiser and I'm working with a set of products that we are, let's say it's the end of the autumn-winter season, we're approaching the sale period, and I want to know, I want to clear out a certain amount of my stock within the first 2 weeks of the sales. So I would want to set a target for that by a % of my total stock of products. So here, after we've uploaded the CSV, I have a list of the products that I need to review. There's 5 in this CSV, so we've got a small data frame showing that. And I would set my sales target, and that is how much of my total stock do I want to move within the first 2 weeks of the sale period. So I'm going to set my sales target at 30%. Once I set my sales target, you can see here on our sidebar, we have a nice summary of what we have in the data set, the total stock of products, and with the sales target we've set, the target of products I want to move within the first 2 weeks of sales. And if I reach about 90 or so % of that target, I would be happy. So the next step is to move on to the Markdown selector, which will, for each product, show me first an image of the product, which looks nice, and then the curve of predicted sales. So for this first product, this kind of cardigan, we have a chart showing the predicted 2-week sales for each markdown that you have as an option. And you can see as the markdown increases, that your predicted sales also goes up. And so for this product, looking here, it looks like you could potentially set it at 30, but this is also a cardigan, so it's something with industry knowledge. I would know this is something after the autumn-winter sales are over. I can still continue selling this in the spring-summer period. So even though it looks a bit like I could set it at 30%, I might set this at 20%, just because that means it would. I know that I'll still be able to sell this product after the sales. And then once I select my markdown on this slider, I can then click on select Submit Markdown. And in this data frame at the top, you can see it's updated to 20%. And then I can move on to my next product, which is here we have a nice little raincoat. And look at the curve again. For this one, I would probably set this one 30 or 40. And again, a lot of this, we have the chart that's showing me what the predicted sales are, and I can use that as a starting point and then use sort of industry knowledge, because this is kind of a human decision where I know that a winter coat would not be something I would sell after the winter season, and I would set a higher markdown. So I can submit that markdown and move on to my next product. And you can see here, as I move through the data set, I have a nice progress bar that's showing how much of my target I have achieved for my goal sales target. So moving on to this little sweatshirt, I can see again, we have our chart that gives me the predicted sales. For this one, I think it would be good to set at 30. For some of these, it's easy to see where you reach a certain point and the markdown 30 for this one, for example, is enough of a markdown to sell a good amount of products. Any higher markdown would be kind of a diminishing return in terms of how many products I can sell and keep a good margin. So I'll set this one to 30 and submit, and then move on to the next product. And this one, again, it's a dress. It's a common solid color that looks good. So with basic kind of knowledge of the industry, I know that this would sell continuously through multiple seasons. So instead of 30, I would set this at maybe a 20 and submit that markdown, and then move on to my last product. And again, this one is another dress. It's in a popular pattern, and I know that it would sell a lot. And I could set this markdown at, I think 20 would be good. It looks like we could have about 578 units sold here. So I can submit this markdown, and then I've gone through my whole data set. And now that I'm done, I'll move to my final page, which is the summary page. And what I can see here is I have a predicted summary of what the 2-week sales is going to look like. And it gives me what my target is based on what I said at the beginning, the predicted total sales for all of the products in my CSV that I uploaded, and the percentage of my goal achieved. And so right now I'm at 85%, which is all right, but if I wanted to, I've set some of these maybe a bit conservatively, so I can go back to the Markdown selector and select another product that I think maybe there's more potential to set a higher markdown and sell more products. So I can move this one up to 30 and move back to my summary, and here I can see that I've now set 92% of my goal, which I'm happy with, so I'm going to go ahead and download my CSV, which once I open will show me the markdown of the the markdowns that I've selected and all of the predicted unit sales for our first 2 weeks. And that's it for the demo. So thank you.
I'll invite the rest of Team Markdown to the stage, and we will take any questions from the audience, if there are any. Yeah.
So what would be your next steps to improve this?
Yeah, sure. So initially the markdowns were all set to 0. So I think a good next step would be to have some kind of initial prediction of those markdowns. You can do that by looking at the graphs themselves and kind of working out where the elbow happens and where the percentage decrease increase doesn't really change too much. Or once you set your 30% sales target, work out for which markdown for each product you would need to clear 30% of each of those products individually. Yeah.
Thank you. Any other questions?
Yeah, so I'm just wondering, the model that you picked, what other models did you consider? Why did you pick that?
So I think the initial model we picked was a k-neighbors regression, I think because of the nonlinear relationship we observed in the data. But when it came to boosting, I think we chose the histogram-based approach because of the outliers we saw in the data. So when actually it came to sort of formulating a decision tree, when you bucketed data in a certain way, so you had like an underflow, overflow bucket, it actually dealt with those outliers well, and actually the root mean squared error fell down quite dramatically. So that's why we've reached that conclusion.
Any other questions? I think that's it. Okay, thank you so much.